So we're going to try and show how we would use Desmos on page 18, problems that we've already done. So just to see how we would use the software. Here we're given the points 3, 3, 3, minus 1, minus 1, comma 3 are three vertices of a square. So we know these are the ordered pair. This is the x value always first, and then the y value. Find the point that is the fourth vertex. So in other words, we're given 3 points of a square, and we're asked to find what are the coordinates, what are the x and y value of the fourth point. Rectangular coordinates are entered using this kind of notation here. So we need the square bracket here. And you can see here I've entered the point 3, 3. For multiple points, a comma should appear between the points. So you see I've got a comma here. So in box 2, we've entered the 3 points given in the problem, and one can see that the fourth point is where the fourth point has to lie where x equals 1, the intersection of x equal to 1 and y equal to 1. Okay, so what do I mean by that? Sorry about that. Okay, here are the points. So first of all, we have the point 3, 3. By the way, this is my label that I've labeled. It doesn't appear in Desmos. This is 3, 3 right here. So x is 3, 1, 2, 3, and y is 1, 2, 3. Here is x is 3, so we go down, and then y is minus 1, so here's y minus 1 right over here. This is 0, and this is minus 2, this is minus 1. Don't forget this is the y-axis, and this is the x-axis. So we know this point, we know that point, and we know the point minus 1 comma 3. So x is minus 1, which is right here. And then we go up till y is equal to 3. So Desmos automatically puts these points in. And they're color-coded over here. If you don't want to see the points, you can just click on them. Now, I've realized that the intersection, the fourth point, if this is one point and this is another point, this is another, and they're at the corners of a square, then this point over here must be at the intersection of x equal to minus 1, which is right here, and y equal to minus 1. So I just draw along here, if you like, and down here, I draw a line down here, and I draw a line from here to here. This intersects at x equal to minus 1, y equal to minus 1. So that's the fourth corner of a square. So now if we go to page 18, number 4, we're asked that the points 0, 0, 1, 2 lie on a straight line. Find another point on the line. So if you look at this, maybe you really have to look at this point and realize that this point is double that point. The y value is double the x value. So, and if you double 0, it's still 0. So if I choose another point, for example, the point 2, and I double it, I get 4, just like I took 1 and I doubled it and got 2. Or if I chose minus 1, and double it, it gets minus 2, then always the y value is double the x value. And then I put these points into box 5. Now essentially what I've turned off is boxes 2 and 3 so they don't interfere. I can just click on this and this. And now in box 5 I've entered all the values that I think would lie in a straight line. Now, by the way, this is just an insertion point, so when I copied it, I didn't click outside the box, so don't worry about this. The points are 0, 0, 1, 2, 2, 4, and minus 1, minus 2. And here they are here. 0, 0, 1, 2, 2, 4, and minus 1, minus 2. So these are all entered here in box 5. And you can see that they do lie on a straight line. So we were given 0, 0, and we were given 1, 2. We chose 2, 4, and minus 1, minus 2 as two other points. You can choose any points you want. You could choose 3 and 6, minus 2 and minus 4, and they would still fit on the straight line. Now, there's another way of doing this, and that is we can use Desmos ability in box 6 now. We can put a table value in. And here you see are the table values that we put in, the same values that we put in over here. We put them in as a table value in box 6. We click off this box so it doesn't appear. We don't want the values here. We want to show the values of here. And what we get is we get the 4 points showing. These are the orange points now are the values shown from the table value. Okay, and they're right here. And the way that we get the 4 table values are right here. The same numbers, as I said, that we entered over here. And if we click right at this point here, we have to click on here after we enter the table values. It will connect the points, and this little box clicks up and we can connect and show the points. This is when you click on this little box over here and we get this. So basically we have different ways of doing this. We can do it by visual inspection, which is right over here. It's pretty much clear that these points lie on the line. We can do that here. Or we can actually enter a table of values, in which case we will get this, and we can connect the points to show that they lie on the straight line. So these are 2 alternate ways to handle this problem. Page 18. Number 7, find the area of the triangle with the vertices minus 3, 0, 0, 5, and 7, 0. So first of all, what I did was I entered minus 3, 0, 7, 0, and 0, 5. And that essentially just gives me these points here. This one here, which is 7, 0. This one over here is minus 3, 0, and this one over here is 0, 5. Oh, I made a mistake here. I'm sorry. Let me go that over again. Minus 3, 0 is this one, right? And 7, 0 is this one. This point here is 0, 5. This one over here. 0, 5 is this one here. 7, 0 is this one here. And minus 3 is this one here. And that's all I get from showing that. I'll just get the points. Now what I did was I put a table of values into 2, 3, and 4 and put the minus 3, 0 and the 0, 5 in. So that would be minus 3, 0 and 0, 5. And you can see I connect the points joining these 2 lines. Then I put minus 3, 0 and 7, 0, which are these and these, and I connect these. The way I connect them is to do that just here. This is just an all way of solving the problem. And then I can connect this point to this one, which is done right here. 0, 5 and 7, 0. So 0, 5 is right here, and 7, 0, and I've connected. So that way I can show the triangle. Now, you know that the area of a triangle is half the base times the height. The height is sometimes called the altitude. So I take the distance from here to here. And you can see that this is 1, 2, 3, and 7 units over here. It's 10. So the distance between -3 and +7 is 10. The distance here is 2, 4, 5, so the height is 5. And the area is equal to height, half the base times the height, a half. The base is 10 and the height is 5. 10 times 5 is 50. 50 over 2 is 25. Or you can divide 2 into 10 and get 5, and 5 times 5 is 25. So essentially, I took the 3 points that were given in the problem, set up a triangle, identified the base. Notice there is a right angle right here. So there's a right angle here between the height and the base. So right here is a 90 degrees. And so I've got the base, the distance between here and here. I've got the height that is 5. Now you may be able to do this without Desmos. It's just a useful way to be able to understand Desmos and see how you can exploit its capabilities. We put the 3 points in here, which gave me this point, and that point. And then I used the table of values to connect the points, different points, the lines joining the different points, right here, and right here. So you can try that on your own and see if you can make it work.